calculus, you already know basic differentiation rules. If I tell you that fx was equal to negative 2x to the power 3 minus 4x squared plus 2, what is the differentiated? The gradient of that. What do you do?
Negative.
Exponent times coefficient is negative 6x to the 2 and negative 8 x to the 1 as a derivative. And okay, so that's it. Now we're not going to do it that way. We're going to do it first principles. Now first principles is using a formula, and the formula says on your formula sheet, you'll find this formula. Why would we want to do it on a long way? Because you need 5 marks. And this sum will be 5 marks. Okay. Please tell me, quick shortcut method. What is the derivative of this sum I'm giving you?
Negative 12x.
And you're absolutely right, and you have absolutely no marks. Shame. If I say first principles, you have to use this formula, and it will for sure, just like a theorem will be asked to prove in geometry, for sure you'll have a first principle sum. So it's something everybody can bargain on. So if you're struggling to pass maths, make sure you can do the stuff that you know is going to be there. This is going to be there. Now I still have to tell you what it's all about. So basically what it comes down to, without getting into too much, it's gradient, guys. And the gradient is the difference between the two y's over the difference between the two x. What am I talking about? Whenever you did the gradient between 2 points, you used that, right?
Yes, ma'am.
Now look at it. It's function notation. Now in function notation, we say that this is y, right? Now what they're saying is you've got 2 y's, which is absolutely right. And the x here at the bottom, oopsie, they just say h. But what did this tell you, that small little piece of limits that I did with you? It's tending to be nothing. So what they're saying here is that the distance between the two x's, these points that you've got here, x1 and y1 and x2 and y2, they want it so close together that the distance between the x's tends to be nothing. That's what they're saying. They want these points to get so close together that they're actually on top of each other. So that they're going to work out the gradient in the specific point. That's the background. So that you know that you're busy with gradient. Because here as well, they say that the y, the x value of the one is x, and the other one is something added. And that something is almost nothing. Tends to be 0. I want the points to be on top of each other, basically. All right, now the way that it works is then you substitute. This is a substitution sum. Very importantly, notation. You cannot ever get rid of that lim here until you have substituted it. Why haven't I substituted it?
Because 0 will be undefined.
Because then it will be underneath the line and it will be undefined, and there goes your sum. Poof, gone. And 0 marks. So there will always be a routine procedure here, making sure I don't substitute and get 0 underneath the line. So therefore I'm going to substitute the fx plus h. What does fx plus h mean? Back to grade 10. If you say f6, what does it mean? What does it do if I say f6? Substitute the x with this 6 into your sum. What must I do here? I must just write fx as is. But what must I write here? In the place of x, there must be a x plus h. In the place of x, I now have x plus h. Read the notation. Fx, fx plus h. So x is being substituted with x plus h in my sum, whatever my sum is. And my sum is minus 6x squared. But now x is not x anymore, x is now x squared. That is function notation. Whatever's there in the bracket, that's what I substitute into my x. Whatever's there, if it was a plus x and whatever there, every x has to be substituted with x plus h. Next one. So now I'm going to minus with what? fx, just as it is there. So it's going to be minus of minus 6x squared. And you're always going to find that because of the minus, these signs will always change. So whatever that sum there was, it's going to be plus now. Do you see it? It's always going to happen. There's routine here. There's things that's always going to happen. And the h here at the bottom just has to stand there and keep quiet until I'm done with it. Because I can't substitute the h. And until I can, this has to still be standing in the front. Please take note. You can't have equals here in the middle. It's a notation error. Okay. So, what must I do then? Simplify. How? Distribute first.
No.
First do the bracket, right? Now guys, you're going to do this so many times in first principles that you're going to know off by heart. That when you take x plus h and you square it, it's going to be x squared plus 2hx plus h squared. If you need more steps to show yourself the two brackets, to show yourself the FOIL, to show yourself the simplification, you go for it. Okay? But you're going to do that specific x plus h a lot because of the formula in square. And then this is going to be plus 6x squared over, and still I have a problem. I would like to substitute. Ma'am said substitute. I can't. I still can't. Let's still simplify there at the top. What's it going to be? Minus 6x squared. Minus 12hx, hx, same thing, but we always do it alphabetically, right? And then minus h squared and plus 6x squared over h. Everybody happy on that? So minus 12 and obviously minus 6, I've missed it. Minus 6 there. Happy there?
Yes.
Still that's there. Please make sure your equal sign is there and not there. Okay? And can we still simplify? Can we substitute? Still not. I have a problem. When we simplify, something unique is going to happen that happens every time with these sums. When you have one term here, over here when you simplify, one term is going to cancel out with one term. It doesn't have to look the same as that. But if there were two terms here, and you rewrote it and simplified, there would be two things cancelling out. I'm saying it, but you're going to see it when you start practicing. And then what's left? Something that I still have to sort out with the h at the bottom. That's a problem. The sorting out of the h is always going to be.
Or HCA.
Because you cannot cancel out. So you're going to take out a common factor. What's left? Minus 12. Ma'am, can't I take out a minus 6? Yes, you can, but what is your purpose here? I want to get the h away. That's my only purpose. So I could take out minus and I could take out 6, but I'm not going to. My purpose is to get rid of that h that is bugging me from the start. I would like to substitute with a 0 and I'm not allowed. So now that I can, I'm going to take out the h. What's left is minus 12x and minus 6h. And still the lim is here in the front. The limit of h tends to be 0. So can I now substitute the h? Now that I've simplified and I've made my problem disappear, the h is not at the bottom, I can substitute. For my first example, I'm still going to rewrite this as minus 12x minus 6h. But you could have immediately now substituted. Where? H must be 0 and the rest will still just be minus 12x minus 6 times 0 is still going to be 0. And I'm very happy to say it's right. You knew it from the start. But if you write this answer only, you will not even get 1 mark. 0. Because it's first principles. You see that we need to practice more.
Yes.
I want to do one more for you. Okay? Right. Next example, now a cubic expression in here, and I'm saying first principles. Please quickly do it shortcut so that you know that your answer to be the answer of what? 3x squared
Plus 1.
plus 1. That has to be my answer. Just writing that, 0. So we need to fill it in here. Now here's the little piece that I didn't do in the first example because it was nice and small. But this can get quite chaotic when you substitute the fx plus h here. And fx plus h means that you've got to go there and substitute this x with x plus h and that x with x plus h as well. Maybe it's a little bit too much for one sum. I'm going to change it. Okay, sorry about that, but it's going to be too much for your second example. So let's go for this one. It should be 3x squared, right, still? But now, to do that actual sum, I'm going to say, please do this, fx plus h first. Simplify it, so that when you get to your formula, you can just put it in there. Because it gets quite a lot and quite big and quite messy. And everybody does it this way, you can go check. Okay. Let's do the fx plus h first, meaning that'll be x plus h to the power of 3. What must I do here? It's 3 brackets, yes. It's 3 brackets. X plus h, x plus h, x plus h. And like Ma'am said to you in the first example, please learn off by heart that one of these x plus h squares is always going to be, because it's going to happen all the time. When you do the calculations, hx and hx, it's you're going to get there. But now for this horrible sum, we still have to do another step. And time in the x and time in the h, which is going to give me x to the 3 plus 2hx squared plus h squared x. See how Ma'am is always keeping to it being alphabetical, so that if there's something that's similar, I can see it better. So then the h going in is going to be plus hx squared plus 2h squared x and plus h cubed. Everybody with me on that? Yes. Am I done? No, because I can still simplify. So now all of this had to have been here, together with all the other stuff. Can you see the mess? Mm-hmm. That's why we do it first off. So we're having x to the power 3, then the hx squared plus that hx squared is going to give you 3hx squared. And these two are going to give you one of them, and two of them is 3. And there's some of them that you can actually learn off by heart, but you've got enough to learn off by heart. Plus h to the power of 3. Okay, so now in here, I'm just going to write x to the 3 plus 3hx squared plus 3h squared x plus h to the power 3. Inside of my formula, lim h tends to be 0 over h, and then this minus will be minus what? Where's fx? Where's fx? It's just the original x to the power 3. And remember what I said to you? If there's one term here, then 1 will cancel out with 1. Do you see it happening? Yes. If there were 2 terms, like I originally had, then 2 terms will cancel out here. It's just a phenomenon that you can bargain on. If there were 3, 3 would cancel out with 3. Okay. So the rest of the sum is now what? Because now, right from the start, we can't substitute the h, can't substitute the h, we still can't, but we can now take out a common h. And if we do take out the common h,
It's squared.
still keeping the lim here. Don't be lazy and say you're going to put it back at the end. You are not allowed to. You take out the common h because this is my focus. I don't care if there's anything else to take out. Was there something else to take out? Well, no. But even if there was, your purpose is to get rid of that h. Taking out the h, what's left? 3x squared plus 3hx plus
h squared.
h to the power. Are you with me, everybody? Taking out a common h, making my problem disappear. So now you don't have to rewrite it again. You can immediately now say, the moment that you substitute that 0, you don't have the lim here anymore. You can't have 3x squared plus 0 plus 0 and still have the lim here. Is it necessary to write that whole thing out? Could I not in my mind have said, okay, well, if that is 0, it's gone, and that is 0, it's gone. The answer is just 3x squared, so you could have left out that step. And the answer, again, making me happy, because I knew that should be my answer. So you start off with your crib note, knowing where you're aiming to. And how many marks? If we're lucky, 6. But it's definitely always 5. Okay.
Boy.